Hello everyone. Today's joke of the day is, why did the teacher wear sunglasses to school? Stay tuned to find out. Our learning target for today is I can solve systems of equations using the substitution method. Okay, so we're going to learn a new method. We already know about graphing, solving systems by graphing. So this time we're going to learn a new method that doesn't involve graphing. Okay, so remember, a system of equations involves two equations, or it could be more, but for our purposes, we're just going to look at ones with two equations. The solution, I'll fill this in here, the solution to a system of equations is the point where the graphs of the equations intersect, and because it's a point, we always write it as an ordered pair. Okay, so remember, think about the graphs. It's the point where they intersect. In some cases, they intersect in an infinite amount of points if they're the same line. Or maybe they won't intersect at all if they're parallel, and then there won't be any solutions. Okay, but for the most part, there's one solution, and that's where the graphs cross. Okay? So we are going to learn to solve some systems of equations using substitution. Now we've used substitution before, right? Like we would, if we had some sort of thing, we had like y equals 2x plus 4, where x equals 7, and then we would substitute 7 in for x, and we'd end up with y equals 2 times 7 plus 4. And then we would solve to figure out what y is. Okay, so that's substitution. So we're just taking this number, and instead of having an x, we're substituting that number in for x. Okay, so we're going to do a very similar thing here with our equations. Now, instead of substituting in just one number, we're going to substitute in a whole expression. Okay, so for this first one, we have y equals 2x plus 1. So we had x equals 7, and then we would substitute in 7. In this case, we're just going to substitute in this whole thing for y. Okay, so I'm going to erase this part here, x equals 7. Okay, so we're going to substitute this in. Substitute this into the second equation. Substitute okay, so we'll actually end up with an expression that looks like 2x plus 1 equals negative x plus 4. Okay, and now we have an equation that only has x's in it. So we can solve the equation to figure out what our value for x is going to be. That will be the x coordinate of our point. So here we go. First thing we want to do, if we have variables on both sides, this goes way back to solving equations with variables on both sides. First thing we want to do is get all of our variables on one side and all of our constants on the other side. Okay, so here, I'm going to draw in this. Okay, get all our variables on one side. So I'm going to take this negative x and I'm going to add x, which will cancel out that x there. But if I added x that side, I have to add x to this side as well. Okay, so then I'll end up with 3x, because this is a 1x, remember, plus 1 is equal to 4. Now I want to get my constants all on the other side, so I'm going to subtract this one, which will cancel that out, subtract 1 from both sides. So we get 3x equals 3. And now we can just solve for x by dividing by 3 on both sides. That's the inverse operation there. And we get x is equal to 1. Okay, so we know that x is equal to 1. Now we just need to figure out our coordinate for y. So we figured out our x coordinate is 1, and we need to find our y. Well, luckily now we can substitute this 1 back into either one of our equations to figure out what y is. I'm going to take the first equation here. So we're going to say y is going to be equal to 2 times 1 plus 1. So we'll take y is equal to 2 plus 1. And then we know y is equal to 3. Okay, so if x is equal to 1 and y is equal to 3, our ordered pair for our solution, that is going to be our full solution, is going to be the point 1, 3. And if we were to graph these lines, we would find that the point 1, 3 is where they cross. So this is our solution, the ordered pair 1, 3. Okay, and we can always check our answers to make sure that we have the correct solution by substituting this point into each of our equations, and they should give us true statements. Okay, so what we would do is we would take 3 and substitute it in for y and 1 in for x times, well, we just did it in this one, so we know that it works. But let's do it in the other one. Okay, so I can take 3 substituted in for y and 1 in for x into our second equation, so we have negative x plus 4. Okay, and then 3 equals 3. Okay, so we checked it, so we know that it works in that equation. And we can actually do it with the first one too. We'll take 3 equals 2 times 1 plus 1. 3 equals 3 plus 1, or 2 plus 1, sorry. 2 plus 1, 3 equals 3. Okay, and because both of those equations then give us true statements, 3 is equal to 3, we know that this is going to be our solution. All right, let's look at another example here. We can substitute. I'm going to take my first equation again and substitute it in to my second one here. So we'll take negative 4x plus 12 equals 3x minus 16. Okay, and I want to get all my variables on one side and all my constants on the other. So I'm going to move my 3x to this side by subtracting 3x. And I'm going to do this in the same step. I'm just going to subtract 12 on both sides as well. So those will cancel out, those will cancel out. Now we combine like terms. Negative 4x minus 3x gives us negative 7x, and that will be equal to negative 16 minus 12 is negative 28. We divide both sides by negative 7. So x is equal to a positive 4 because those negatives will cancel out. Okay, and if x is equal to 4, then we substitute that in to figure out what our y is equal to. Okay, so I'm going to substitute this into the second equation. We'll take y is equal to 3 times 4 minus 16. So y equals 12 minus 16. Y equals negative 4. So our ordered pair, that will be our solution. That is, our solution will be 4, negative 4. Okay, x comma y as always. That's our solution. All right, let's look at this next example. Okay, this one has some fractions, but we don't need to be scared of that. We can do exactly the same thing that we have been doing, and it'll actually work out pretty well for us here. So we'll take negative 1/2 x minus 3 when we substitute that in for y is equal to 3/2 x plus 5. Okay, and I want to get all my x's on one side and all my constants on the other side. Okay, well here I'm going to add a 1/2 x to both sides, and I'm going to subtract 5 from both sides. So those will cancel and those will cancel. So you get negative 3 minus 5 is negative 8. And that's going to be equal to, well, we have 3/2 x plus 1/2 x. And since they have a common denominator, we can just add the numerators. So that's going to be 3 plus 1, which will be 4. 4/2 x, which is really equal to just 2x. Okay, so that actually works out pretty nicely for us. We don't really have to deal with those fractions too much. Then we divide by 2 on both sides to get rid of that 2 in front of the x. And we get x is equal to negative 4. Okay, and if x is equal to negative 4, then we'll substitute that back in to figure out what y is equal to. Let's substitute it into our first equation. So we'll get y is equal to negative 1/2 times negative 4 minus 3. Y equals, well, half of 4, well, the negatives will cancel, so those will be positive. And half of 4 is 2, so we get 2 minus 3. Y is equal to negative 1. So our ordered pair, that's our solution, is going to be negative 4, negative 1. And if we substitute that in, we could check our answer, but I'm not going to do that right now for the sake of time. All right, and we have one last problem here. So let's substitute this top part for y into our second equation. We get 6x minus 10 is equal to negative 2x plus 2. And then we can solve here. So let's get all of our x's on this side. The opposite of negative 2x is going to be positive 2x. Add in 2x. So those will cancel. And then we'll add 10 to both sides here, 2. So then we get 6x plus 2x is 8x is equal to 12. Okay. And then we'll divide by 8 on both sides. And that will cancel out. We'll get x is equal to 12 divided by 8. Well, we can simplify that. They both have a factor of 4 in them. So we'll divide this by 4, divide by 4, and that's going to be equal to 3 over 2, which is also equal to 1.5. So you could say x is equal to 3 halves or 1.5. Okay? And then we'll substitute that back in to find out what our y is equal to. We'll do that to our first equation. Y is equal to 6 times 3 halves minus 10. And I left it as 3 halves because you'll see this will be a little bit easier for us. This is like 6 over 1. So we can take out a factor of 2 here, and that leaves us with 1. If we take out a factor of 2 there, and that leaves us with 3. Now we'll just have to multiply across. So you get y is equal to 3 times 3 is 9 minus 10. So y equals negative 1. So our ordered pair here is going to be 3 halves negative 1, or you could write it as 1.5 negative 1 because it comes out as a nice decimal that does not repeat. Okay? So when we are given 2 equations for a system, we can solve that system of equations by eliminating one of the variables. Okay, if we have y is equal to something with an x term, we can eliminate the other y variable by substituting that whole term in for y, that whole expression. And then we can solve for x and then solve for y afterwards. You could also do this with x if you had x equals something, an expression involving y. So now for today's joke of the day. Why did the teacher wear sunglasses to school? Because her students were so bright. Thanks for watching and have a great day.